Okay, hello everyone. This video I'm going to finish the homework problem 11.60. Okay, 11.60. Okay, in previous two video we already find a neutral axis and the moment of inertia of this cross section. And finally, we can answer the problem. Okay, he said it give you there's a beam, there's a cross section, and it give you the maximum allowable tensor is 14 megapascal, and maximum allowable compression is 21 megapascal, and determine the maximum internal moment. Okay, so for the moment, for the bending stress calculation in the beam, finally you need to have this fixed picture in mind. What kind of physical picture? Okay, the physical picture is like this. Okay, so let me draw. Okay, if this is the neutral axis, okay, if this is the neutral axis, okay, and there's okay, let's say there's a bending moment here, and then okay, and then we will have the shear shear stress distribution. Not shear stress, the bending stress distribution, and the bending stress distribution is grow linearly along with the linear along away from the neutral axis. So, and above is compression, and above is compression. So there is the maximum. Okay, so this is a maximum, and below is the tension, and below. Okay, maybe we just draw here. Okay, below is tension. Okay, that's you have to this picture in mind. Okay, that's the bending stress distribution in the cross section. Okay, with respect to neutral axis. Okay. And so we see in the picture we see the maximum always at the surface. Maximum is always at the surface, or top surface is on top. The maximum is always at the top surface or the bottom surface. Okay, the top surface and bottom surface always have the maximum compression or maximum tension, maximum compression. Okay, so and the top, what's the distance? Distance from top. What's the distance between the top and the neutral axis? Okay, so let's go back to this picture. You forget it. Okay, so before we calculate the neutral axis is 84.72 millimeter away from the bottom. Okay, so here is 84.72. Okay, so here is 84.72. Here, 84.72. Okay, and what's the distance between the top and the neutral axis? Okay, so let's go back to this geometry. Okay, so what's the distance between the top and to the neutral axis? Very easy, because the total height is 100 plus 25 plus 75. So totally is 200 millimeter. So the distance between the top and the neutral axis is 200 millimeter minus 84.72 millimeter. Okay, so distance here is, okay, let's take a note here. Okay, it's 200 minus 84.72. So what's the value? Yeah, let me see. It's 115.28. Yeah, don't forget our units is millimeter. Okay, so the maximum is always at the surface, at the top and the bottom surface for bending stress. Okay, so the maximum compress is, oh, okay, let's do this calculation. Okay, the problem gives us the maximum compression, right? Okay, let's say, okay, the max compression. Okay, so it's equal to, okay, let's say if we have maximum compression, okay, maximum compression is at surface. Okay, so we will have the M max and times y. Okay, y is the distance to the neutral axis, and the maximum compression is always at the top surface. And we know the top surface, the distance between top surface and neutral axis is 115.28. So the y is 115.28 millimeter. Okay. And our I is, yeah, we just calculate, is 2.3152 times 10 to the power minus 5. And the problem gives us the maximum compression is 21 megapascal. It's 21 megapascal, 21 megapascal. So it's 21 times 10 to the power, 10 to the power 6. And the compression, so there's a negative sign, and the formula there's a negative sign, but this will cancel out. So if we choose, so let's do, so if we use the value maximum allowable compressed stress, okay, and then we will have the maximum, we will have a maximum moment is, yeah, you can do this calculation, it's very easy. We will have maximum moment is, this is 4.22, okay, 4.22 kilonewton times a meter. Okay, yeah, that's the maximum moment if we choose use this value, maximum compressed stress given by the problem. And okay, so okay, we need to have do another test. So the problem also gives us the maximum tensile. Okay, so and then equal to, yes, this is here. This is also the minus and max and times. Okay, we just use these two extreme value and then determine the reasonable maximum moment of the allowable maximum allowable moment. So the maximum tension is always for this problem as at the bottom surface. So and we know it's 84.72 away from the neutral axis, and we use the neutral axis as the reference point. So this actually is minus 84.72, minus 84.72 times 10 to the power minus 3. Okay, yeah, why is the response so low? And I is the same. 2.3152 times 10 to the power minus 5. Okay, so we use the other extreme value, the maximum tensile stress, okay, and then we will get another maximum moment. So our Mmax will be, okay, so it's probably, if you do this calculation, the maximum it's about 3.83. Okay, it's about 3.83 kilonewton times the meter. Okay, so we have two value for the maximum allowable moment. Which one? Which one is the answer? Which one is the answer? Mm-hmm. Yeah, the problem want us to determine maximum allowable moment. Okay, so it looks like we have to it looks like because we want the maximum value, it looks like this is the answer. But actually this is not the answer. Okay, why? Because we want to find allowable maximum moment. Okay, so if we use this maximum moment to calculate the maximum tensile stress, what will we get? Okay, if we use this value to do the maximum, if we use this value to calculate maximum tensile, what will happen? Okay, maximum tensile. Okay. I don't respond so quickly. So if we use this max moment, okay, and minus 4.22 times 10 to the 3, and times, because the maximum tensor is always at the bottom surface, so it's minus 84.72 times 10 to the power minus 3. Yeah, it doesn't respond very well. So it's the I is 2.31 and 2.3152 times 10 to the power minus 5. So, okay, if we use this maximum moment, we think this we want to determine the maximum value. Okay, so this is greater than this one, but it's really that this is the answer. So we choose this value 4.22 and doing the back calculation to calculate if we have this maximum moment, what's the maximum tensile stress would be. So after okay, you can use your calculator to determine this problem. Okay, actually, yeah, there's a minus sign here, and but they will cancel out. So 4.22 times 84.72 divided by 2.31 by 2 times 10 to the power 5 multiplied by 10 to the power 6. So this will be 15.44 megapascal. Yeah, if we choose this maximum, we choose 4.22 kilonewton times meter. If we choose this value as the maximum moment, and we will have the maximum tensile stress will be 15.44. It's greater than 14. It's greater than 14 megapascal. It's greater than 14 megapascal. That means if we use this as the maximum moment, the tension part will be fail. Okay, that means fail. The material is going to fail. So this is not the maximum value. Okay, this is not maximum allowable value. So this will be the maximum allowable moment. Okay, because this is we use this as a maximum moment. Maximum moment, yeah, it will have the maximum tensile. It's just equal to 14 megapascal. Yeah, so it just right at the limit. And this value also make the maximum compression under maximum also make the maximum compression stress under control. Is really true. Okay, let's use this to the back calculation again. So our maximum and the compression. Okay, so yeah, the response. So we use minus 3.83 kilonewton. And maximum compression is always is for this problem is at the surface, so it's 115.28 115.28 times 10 to the power minus 3, and the hour is the same 2.3152 times the 10 to the power minus 5. Okay, so if we use this, so what will be okay? Okay, 3.83 times 15.28 and divide 2.3152. Okay, times 10 to the power 3 divided by 6. So it will be 19.07 megapascal, and it's lower than 21 megapascal. Okay, so that's why we choose the lower value for the answer. Okay, because we choose this value, this will create the maximum tensile stress greater than greater than the criteria given by the problem. Okay, so if we give it this is maximum moment, it won't fit this criteria. But if we choose this 3.83 kilonewton times meter, yeah, this give you the this give you the maximum tensile stress, and also the maximum compression stress is 19.07 megapascal, and it's fit the criteria of the problem because this magnitude is smaller than criteria of the problem, 21 megapascal. So that's why this is your answer. The answer is 3.83 kilonewton times per meter. 3.83 kilonewton times per meter. Okay, so finally we finally finished the problem. So this problem is very so long. So we need to find a neutral axis and the moment of inertia, and then finally using the physical picture of bending stress to discuss the maximum allowable moment. So this is going to be a long question and not an easy question. So just so that's why this I give you this as your homework home problem. It give you we will give you kind of a little brainstorm for this problem. Yeah, it's not easy problem. Okay, so I just finished the problem here, and see you in the next video. Bye bye.